Hi, my name is Rosa Trippel and I'm presenting on Spice It Up with Ginger. First off, an introduction to ginger. Ginger is a widely used spice and it's known to have many health benefits. One of ginger's main constituents are gingerol-related compounds like gingerol and shogal, as seen on the right. Gingerol is linked with the pungent, fresh ginger taste. It's also responsible for activating the spice receptors on the tongue. Additionally, it is linked to the anti-inflammatory and anti-nausea effects of ginger. Next is shogal. Shogal develops when ginger is dehydrated. Since gingerol loses its hydroxyl group, it results in shogal. Shogal as well is more pungent than gingerol, and it contributes to the flavor of ginger. Additionally, it has the anti-coughing effects that are associated with ginger. Finally, the initial goal of the project was to determine masses and concentrations of the gingerol-related components for TruEssence foods, and then compare those to that of other ginger products. And then analytical chemistry and organic chemistry sample preparation are mainly involved in this project. The significance of this project involves that it's applicable to a larger audience since ginger is a well-known spice and remedy. One of the goals for the project especially is to focus on food science and how healthy foods can have real-time results, like how ginger shots have become a health trend since they really help with digestion in the human body. If we use the freshest ingredients for cooking, we have the best results. And you can really taste the difference between fresh, pungent ginger and a more subtle, dried ginger. Be sure to test it for yourself with one of our favorite recipes, like chicken long rice. Next up is methods for this experiment. First off, the instrumentation we used is the HPLC, or high performance liquid chromatography, and the GC, or gas chromatography. Both of those separate, analyze, and identify compounds through a column, whether it's gas or liquid. And then HPLC is our primary source of data for this project, but we are working on GC data. We've run it, we just have yet to analyze it. Next up is the ginger extraction method. So the vials you see in image 4, the bottom part, that is a ginger powder that we are extracting into acetonitrile, a liquid, with NaCl, which is a salt, to help expedite the process. And the mixture of the ginger, the acetonitrile, and the NaCl, all of that together is put into a centrifuge, it's vortexed, it is put into an ultrasonicator to try to get all the ginger compounds into the liquid. That liquid from there is diluted with additional acetonitrile, and our internal standard is added so that we can run that on the HPLC or the GC. So all of our extractions are the same throughout any ginger sample, whether it's fresh ginger or ground ginger or powdered ginger. Next up, we have our dehydrated ginger, and we've actually dehydrated our own ginger by using a food dehydrator, and it's seen in image 5. It's cut up slices of thin ginger, fresh ginger. Then we dehydrate it, and then we ground it in an espresso grinder. So that allows us to test our own powder versus other name brands. Next up, we have our calibration curves, which are a way to identify the concentration of an unknown substance. So we created the calibration curves by running a series of standard solutions with a known amount of each gingerol-related component, and then charting as seen here. The peak areas from unknown ginger samples can be analyzed using the calibration curves to determine the micrograms per gram of the ginger sample. And then new calibration curves are required for any varying method on the HPLC. So there's many sets of these calibration curves. This specific set is linked to this set of HPLC data. The bar graph here represents a comparison of temperatures that TruEssence used to dehydrate ginger. So it goes from 60 to 105 to 120 to 135 degrees Fahrenheit for this data set. And the optimal temperature kind of depends on what you're looking for in the ginger sample. If you're looking for more gingerol, then you want to stay around 105 degrees Fahrenheit. If you want more shogal, then you want to stay around 120 degrees Fahrenheit. Depending on which, if you want a more pungent, like ginger taste ginger powder, then you want to stay towards 120 in shogal. If you want a strong ginger taste but not as pungent, not as like punching to the senses, then you want to be more towards the gingerol side at 105 degrees. So it really just depends what type of ginger powder you're looking to make, and that's the type of thing that we're determining with our data and research. So next up is our further research. Again, we've run GC data, but we want to build a further foundation for our results. With the GC data, we just need to analyze it and get back into the lab after winter break. Next up, image 6, we have the color difference between different types of ginger. I'm really interested to see if samples from different parts of the ginger root will result in different variables or different gingerol related component values. So this one in particular is a color difference between two different ginger roots. So since it's a plant, it always differs no matter what it is. It's not always consistent, but I'm interested to see if the ginger component changes based on the area of the same ginger root. So that's something I'd like to pursue next. Additionally, in image 7, you can see the color difference between the fresh ginger and the brushed fresh ginger. What that means is that True Essence gave us samples of both types of ginger, whether it was treated with their specific treatment or not. I'm also curious to see what types of treatment can cause this severe difference, since you can see the color difference between the brushed fresh ginger on the right side is significantly darker compared to that of the left side of the untreated fresh ginger. So that's another area we'd like to go into. And then finally, a lot of the True Essence samples are losing their color over time. So the right side of image 8 shows a really dull ginger color of the powder, versus the left side is a bright ginger. So it shows their degradation of color over time. And we'd like to see if that color degradation is linked with a degradation of the potency as well. So that's some areas of research we'd like to go into next. And then here the works cited. Thank you for your time.